Now, let's talk about VLANs. So, what is a VLAN? VLAN is a network segmentation technique that enables creation of multiple logical networks with a physical network. Now, when we say creation of multiple logical networks, this simply means that we're going to create multiple LANs without the need of relying on physical connections. So basically, we're going to have just one switch. In this case, I will draw the same topology we had in our previous whiteboard session. So this is a switch. I'm going to name it switch 1, and I'm going to connect this to, I will use the same topology. So I have a PC here. I'll call it PCA, and I will have another PC. I will call these PCB. I will have another server, server C, and server D. So basically, this is the same topology that we had in our previous lecture. But instead of using just one network, one broadcast domain, I'm gonna segment the broadcast domain into two using VLANs. And this is how it works. First, I'm gonna specify the interface number, E1, E2, E3, and E4. There you go. And then I will add VLANs. Okay, VLAN 10. Let me do that again. VLAN 10. And then we have VLAN 20. Okay, VLAN 20 is configured on those interfaces connecting to server D and PCB, which is Ethernet 2. So I'm gonna add here VLAN 20. Okay, there. Now, I will also gonna add the network. But before I add the network, what will happen here is if PCA wants to send traffic to an unknown destination, the server will only broadcast the traffic to VLAN 10. Okay, again, we are segmenting the broadcast domain. So only those interfaces that are configured as VLAN 10 is where the switch gonna forward the broadcast traffic of switch A. Now this is the same for PCB. If it's gonna send unknown or traffic to unknown destination, it will only forward the traffic to those interface that is configured as VLAN 20. So in short, VLANs allows us to segment broadcast domain. Now I'm gonna add the networks. So in PCA and server C, I'm gonna add 192.168.10.0. I need a little more space, so let's do this. 192.168.10.0, and this will be /24. If I don't add any prefix, we're gonna use /24 as our default prefix. I'm also gonna add 192.168. This is 20.0/24. Okay. Now, again, PCA can only communicate with server C, as well as PCB can only communicate with server D. Now, here's what we're gonna do. We're going to create a summary of our VLANs. And it's not only VLAN 10 and VLAN 20 that is existing, because we have what we call VLAN 1. Okay, VLAN 1 is our original VLAN. Before we created VLAN 10 and VLAN 20, VLAN 1 is already there. Okay, because VLAN 1 is the default VLAN. The default and the original VLAN. Meaning, if you don't create VLANs, if you don't configure your interfaces, your switch will be using VLAN 1 to the entire interfaces. Okay, that's why switch is a plug and play device. By default, interfaces are up. Okay, it's not deactivated, it's not shut down, and it's using VLAN 1. So plug and play, you can just connect your endpoint devices or your cable connecting to your endpoint devices, and your endpoint devices can communicate to each other using the default VLAN 1. Now in our VLAN database, I will just use VL as a shortcut for VLAN and DB for database. We have VLAN 1, we have VLAN 10, and we have VLAN 20. So this is our current VLAN database. Okay. Now what I'm gonna do is I will add a second switch. I will call these switch 2, SW2 there. And then I will add, or I will connect another server. I'm gonna call this server A, and another server, server F. Okay. I will also add the IP address because we already have a network, but the host IP I'm gonna use .1 for PCA, .2 for PCB, .3 for server C, and .4 for server D. Now I will also add VLAN 10 to switch 2 and configure VLAN 10 on the port connected to server A. I will call this VLAN 10, and then I will also configure or create VLAN 20 to switch 2. Okay, now I'm not gonna add the network. Okay, so VLAN 10 has a network of 192.168.10.0, while VLAN 20 has a network of 192.168.20.0. We'll do a little shortcut, but the host IP address of server A will be 10.5, and for server F will be 20.6 there. And let's say this is E1 and this is E2. That's okay. Now, here's a question. Can PCA communicate to server E? Meaning, can the PCA send traffic to server E? Will it be successful? What do you think? Or PCB, can it send traffic to server F? Will it be successful? Now, the answer to that is absolutely no. And the reason because switch 1 and switch 2 doesn't have a connectivity. There's no connection between these two switches. Okay, so what I'm gonna do is I will add an uplink. Okay, let's call this uplink, or let's use interface E8, and another uplink for interface E9. Okay, so you see what happened there? I created two uplinks. Okay, interface 8 and interface E9 of switch 1. And as you see the colors, the uplink is using a dedicated VLAN. The first uplink, and the second uplink is a dedicated VLAN 20. So the question is, will this work? Okay, if I send traffic from PCA to server E, will it work? Yes, it will work, and it can only forward the traffic to the uplink interface E8 because that interface E8 is configured as VLAN 10. Okay, and for the PCB, it can only send traffic to the uplink on interface E9 because the interface E9 is configured as VLAN 20. Now, what we have here is access ports.